Hi all, I'm Ankur Gupta. Hope all of you are doing well and welcome to Analytics School. Today we are going to discuss about the native data structure types in Pandas. Then we will give an introduction to series, that how you can create a series by using Python built-in data structure like list and dictionaries. We will also be discussing about some important methods in series. For example, head, tail, describe. We will also learn how to extract data in series, basically accessing and subsetting the data in series. To get started with Pandas, one needs to understand that there are two types of the data structure. They are series. A series is a one-dimensional array like object containing a sequence of values. You can think of it as an Excel sheet which has only one column. Whereas a data frame represents a rectangular table of data and contains an order collection of columns, each of which can be of different types such as numeric, string, date, time, boolean, etc. It is just like Excel data with n number of rows and m number of columns with different data types. Now let's get started with the fun part. Let's start coding, and I'll be using Jupyter Lab. You can use Jupyter Notebook, Jupyter Lab, PyCharm, VS Code, and any other IDE to start writing Python code. Before we start writing our code, if you're a beginner, then it is important for you to know what parameters and arguments are. Parameters, one can think of parameters as a variable in a method definition, whereas arguments are the actual values that we pass, that we associate with those parameters. And there are two types of the argument. One is positional and the other one is keyword argument. So here you can see this particular function. We have defined a function called func, and then we passes three parameters, function parameters. But when we run the function, we pass the actual values. So these are the parameters and these are the arguments. This is an example of positional arguments. And later on, I'll show you an example that how we are going to use the keyword based arguments. So let's import our necessary packages and start writing the code. I'll be importing pandas as pd and numpy as np. Now what I'm going to do is I'm going to create a series by using the Python built-in data structure, that is by using list and dictionary. I'm calling the alias and then creating a series. What I'm going to do is I'm going to use the keyword based argument. Now my keyword here is data, and I'm passing the values associated with it: 10, 20, 30, 40 and 50. So this is the dummy data which I'm creating here. Now let's run this code. And if you are using Jupyter Lab or Jupyter Notebook, one can use Shift plus Enter to run the code, or you can go here and run the selected cells or run all above cells. Now the output of this series looks like this. The output is basically a sequence of values with associated labels, and note that we have passed an array or list of values, and Pandas automatically generated labels associated with those values. So you can see here we passed this particular list 10, 20, 30, 40 and 50, and Pandas has automatically generated a label for it: 0, 1, 2, 3, 4. Now let me give an example where we are going to create a series with custom labels. Now you can see here there is a parameter called index. I'll be using that, and I'll be passing custom labels here. Let's see how does it look like. So you can see here we have passed the index. These are the custom index which we have passed them, and you can see they are associated with the values. So this is another way where you can create a series by a list of values, and for index you can create a custom label. We can create a similar series in Pandas by passing a dictionary. Let's see that example. So we have created a series by passing a dictionary, which is again in inbuilt Python data structure. Now let's see some of the other functionalities of a series. Let's say we want to compare two series and see whether they are same to each other or not. What we can do is we can use the equal method and we can compare both the series. So for example, if we want to compare df underscore list underscore custom with df underscore dict series, they are actually the same. And if we want to, and let's say in the real world, if you are working on a data set, they can have millions of rows, and it is nearly impossible for you to see all the records and compare it. In that particular case, you can use this method equals. You can use this method equals and then pass another series. And you see it gives true, which means both of them are identical. Another thing which I would like to let you know, that there is no hard and fast rule that the labels or index are going to be unique. You can have duplicate index also. So let's say if I would like to add another label called SD with the same value, so it is not going to be a problem. There is no hard and fast rule that there cannot be duplicate values or there cannot be duplicate labels. So what I'm going to do here, I'm going to append another series with the value of SD and 40. And you can see here, this is just identical to SD40, the fourth element. And we can also append multiple series by using the append method. Let's do an example. Let's see the output. So you can see here, we are able to successfully append two different series and we have created a new series out of it. As an analyst, when we get the dataset for the first time, we would like to have a look and feel of the dataset. We would like to know how many number of records are there in a dataset. What is the data type of variables are? Does any variable has a missing data? Can we generate some summary statistics of the dataset? So we are going to see these functionalities in a series. Let's have a look and feel of a dataset by using print statement. We have not used it because in Jupyter Notebook or if you are using Jupyter Lab, if you are not going to use the print statement, you will get the same output. You can use just df and you can get the same output. But if you are using any ID like VS Code or PyCharm, you need to use it. Okay, now here is one thing which I would like to let you know. If a data set is small, it will not tell you how many number of records are there. Here you can see length is also mentioned, that the number of records are 19,800 and D type is integer 63. Integer 64. Here you only get the D type, what is the data type of the variable is. By the way, I have created a dummy data set by passing an array between 1000 and 100,000. In a real world, if you are working on a series or a data frame, you are going to have millions of records. And if you are going to use this particular methodology, print df, it might take a lot of time, or it might not be able to print out the whole the data frame, because it has so many number of the records to show it to you. In that particular case, we would like to see the top 5 records or top 10 records, or bottom 3 records or bottom 10 records. That is where the head and tail method comes into the picture. What does head method do is, it will print out the top 5 records of a series, and tail, by default, it will print out the bottom 5 records of a series. Let's see how we can use these methods. Now you can see here we have used the head method, and it prints out the top 5 records of it. And you can also notice that the length is gone. It is not showing you the length. Let's say if you want to see top 20 records, you can pass here n equal to 20, and it will print the top 20 records. If you want to see the bottom 5 records, tail method will do that. Let's say if you want to see bottom 10 records, you just need to pass n equal to 10, and you will see the bottom 10 records. Now you have a look and feel of the data set, but you would like to know that how many number of records are there in a data set. We can use here size attribute. And then you can see it has given you the number of records, 19,800. There is another attribute called shape. And you can see here, it is showing you the number of records, comma, and then it is empty. If it has been a data frame, it would have given you number of records as well as number of columns. And for example, if you want to access number of records only, what you need to do is, you need to extract this element by passing 0. So there are 19,800 records. There is one more way through which we can get how many number of records are there in a series, and that is by using Python's built-in function called len. And it will give you the same result, 19,800 records. Now let's say you want to know what is the data type of the series is. In our case, df seems to have an integer based series. But let's say if it is a customer ID, integer does not make sense. Might be the string makes more sense in comparison to integers. Sometimes you had seen, if you had been working in the real-time scenario, that the date field are saved as string fields. So it is very important for data analyst to confirm that whether the data type which you are seeing for analysis purpose has been saved into the current data type or not. For that particular purpose, what we can do is, we can use the Dtype method to see what is the data type. Now in series, it is very easy to find it out whether it is an integer or not, because here it is already showing you, the head method is already showing you Dtype as an integer 64. But if you want to get this Dtype exclusively, you can use this method. And you can see Dtype integer 64. There is another method, actually there is only s has been added here, and it will also give you a Dtype of integer 64. Now you must be thinking that why series has two attributes for that do the same thing. Actually, in Pandas data frame objects, you only have Dtypes, which is a series with the data types of each column. So in principle, many functions of the data frames already worked with series out of the box. So for series, you can use either of them, but when you will be using Pandas data frame, then you will have an access to Dtypes only. There is one more method called info method, which gives you all these information, that how many number of records are there, what is the variable type is there, how much memory usage is used by this particular series, and that method is called, as I said, info method. Let's use it to get more concise information about a series. So you can see here DF is a series. Range index has 19,800 records starting from 0 to 19,799, and you can say here this is a default index, and series name is none. Non-null count is 19,800, so you can see here it is equal to the range, and D type is integer 64, and you can see here they have also mentioned it appropriately. D types is integer 64, and total memory usage of this series is 154.8 KB. So you can see here this particular method, info method, gives you a lot of information about this particular series. Now let's discuss about a very popular method in Pandas known as describe. It generates a descriptive statistics. Descriptive statistics includes those that summarize the central tendency, dispersion, and shape of the dataset distribution. And remember, it excludes null values. So if your dataset has null values, it will not take into the consideration. Let's see how we can call the describe method for a series. And it's very simple. df.describe. And see, it will give you all the information. How many number of records are there? 19,800. And as I mentioned, it excludes null values. So if you have null values in your series, it will not be giving you that particular information. Mean is 50,497. Standard deviation is this much. Minimum is this. 25th percentile is 25,748. 50th is this one. So mean is equal to median. 75th percentile is 75,246. Max value is this much. We will revisit describe and all these methods when we'll be discussing about the data frames and in more detail. So these are some methods and attributes for series in Pandas. Before we start our discussion on how we can access and extract values in a series, let's revisit to the topic of index in Pandas. In Pandas, we had seen that data aligns automatically by the labels or index. We saw that index is a sequence of number and it starts with 0 and ends at n-1. For example, for a series DF, we have a series of 19,800 numbers and the index starts at 0 and ends at 19,799. And Pandas create the automatic label from the built-in Pandas object called range index. And we also know that we can also create our own custom labels. To extract the element from a series, one can use either position-based extraction or label-based extraction. And there are various ways available to do it in Pandas, such as square bracket notation, dot notation, get method, Boolean masking, and everybody's favorite, ILOC and ILOC. Before we start discussing about the square bracket methodology, let's create one more dataset. We already have DF dataset. Let's create one more dataset with custom labels. What I'll be doing is I will add prefix to the index. Let us use head method to see how the index looks like. It is the same series, but our labels are different. It starts with label _0, label _1. So you can say these are the custom labels. Let's just start our discussion with the square bracket notation. And actually we are kind of familiar with this particular from when we use indexing in Python list to extract a certain element from a certain position using square bracket. And just wanted to let you know, let's say if there is a list of n elements, then indexing n will start from 0 to n minus 1 element. So let's say we want to extract the value from the 5th position in a series. What we need to do is we have to mention in square bracket number 4. So for example, if we want to get the value at index 4, we have to mention here 3. So you can see here 0, 1, 2, 3 and 4. So index 4 is n minus 1, 4 minus 1, 3, which will give you that particular number. Similarly, let's say if we want to get the value of at index position 100, we need to mention here df 99 and it will give you the position at index level 100. And let's verify that. And I'm mentioning here all 100 numbers. And you can see the 100 index level position is 1495, which confirms this. And as I mentioned again, and this is like n number of time I have said this, the indexing in Python starts from 0 and it goes till n minus 1. If there are n number of elements either in a series or let's say in a tuple, list or sets, whatever it is, it will start from 0 to n minus 1. We know head method by default give us the top 5 records. Now let's say by using a square bracket notation, we want to get the top 5 records. How we can achieve that? We are using df dataset, use the square bracket notation, double colon and 5. So now we will get the values at index position number 0, 1, 2, 3 and 4, but not at index level position 5. 5 is not inclusive. So you can see here, these are the top 5 records. Now there is an interesting thing about series is that negative indexing does not work on a series that uses built-in range index method or even when we pass a custom index that constitutes of number. Whereas for Python list, sets or tuple, negative indexing works. For example, if we want to extract the last element, ideally we should have written like this and we should have got the value. Here it is saying -1 is not in range. So negative indexing does not work in case of series. But the interesting thing is negative range works. What do I mean? So for example, here you had seen we were able to extract the top 5 indexes by using the range method. So if we use negative indexing as a range, we can get the result. So for example, tail method gives us the bottom 5 records. We could have achieved it by using a square bracket notation using this -5 double colon and then left it blank, and we have got the bottom 5 record or last 5 records. Now let's do few examples of a square bracket notation on a series that has custom labels, but it does not constitute of numbers. If you remember, we have also created a series called df_labels and then add prefix label underscore. So it has become string based indexes. Now let's say if we want to get the top 5 record using square bracket notation on the series that has string indexes, it will work the same way as it was working on number based indexes or by using the default range index methodology, and you can see we can get the same result. Let's say if we want to extract the position, let's say between 100 to 110, and that is simple. For 100 position it is 99, and then 110 means 110. because 109 is the 110th element of a series. And you can see here we have got the result. Now let's say if you want to get an output for index position, let's say 10th, 19th and 1, and in this particular order only. What we can do here, we will pass within the square bracket notation, we will pass a list. 10th means 9th, 20th position means 19th, and first position means 0. And you see, we have got the values at 10th position, 20th position, and at number 1 position. Now, here is an interesting thing about negative indexing when you have a custom label, and those custom labels that are not numbers. Negative indexing works in the case when a series has a custom label that is not number. And you can see here we have got the result. If I have done the same thing for a series that has index with numerical indexes, this will not work. Till now we have seen position based indexing in square bracket notation. However, when we have custom labels that are not numbers, we can also use label based indexing in a square bracket notation. Let's do few examples. Let me use the head method with our df underscore label series, and you can see here, as we know that label underscore 0, label underscore 1, these are all custom labels. For example, if we want to access label underscore 4 element and its value is 1020, how we can do that? We have opened a square bracket notation and passed label underscore 4, and it gives you 1020. Now you might have noticed, let me just write here, let me use position based indexing. So in this particular case, if I have to access the element 1020 for label underscore 4, I have to mention here 4, because n minus 1 element we are going to access by the position for position based indexing in square bracket notation. But for label based indexing in square bracket notation, we mention the label as it is to extract that particular number. Now, there is one major difference between position based indexing and label based indexing in series is, so for example, if we are passing a range of labels to extract the elements, let me write the code first. So for example, I want to access the label from, let's say, label underscore 5 till label underscore 20. So I passed here label underscore 5 because in label based indexing we have to mention the label as it is. Till label number 20. So in previous example we have seen, if we need to get the element from 100 to 110, we get since label underscore 99 is 100 position, we passed it from 99 onwards, and 110 is not inclusive, it is exclusive. However, when we use label based indexing, it is inclusive. The last element is also inclusive to get the labels. So you can see we have got the label 5 value till label 20 value. So these are the key differences when we use label based indexing in place of position based indexing when we are using square bracket notation. If you have a custom label in a series that is not a number, then you can also use dot notation to access an element, just like we access an attribute of a series. Let's do an example and see how we can use dot notation to access a particular element. So we have df underscore labels, we are going to use it, and let's say we want to access an element at position number label underscore 20. Just like we call any other attribute in a series, for example shape, similarly we can call label underscore 20 to access that particular element of a series. And you can see here we get value 1100. Similarly, if we want to access, let's say label underscore 1000, and you see we got the value 6000, which is the value associated with label underscore 1000 index. But it is my recommendation, never use dot notation because it has some serious limitation. And what are those limitations? For example, let's create a series, and here I'm adding a prefix in df series as label, and then I'm having a space there. Let's see how does it look like. And you can see here label, then there is a space and then 0, and the value associated with that particular label is. So for example, let's say we want to extract label 4, the value is 1020 associated with that particular index. Using dot notation, we will get an invalid syntax. df underscore lab dot label. Now when we will put up a space and 4, Python will consider it as an invalid syntax, because when we call an attribute, we do not pass any spaces after that. And if we are going to put any number or any other thing after that, it will consider it as an invalid syntax. See here. For example, if we have to access this particular element label 4 by using custom label using square bracket notation, we could have done it. And we have got the value of 1020. Another issue with the dot notation is that we cannot extract a subset of a series. For example, labels dot label underscore 0, we can extract this element. But let's say we want to extract the top 5 elements of this series, we cannot do that. As you can see, nothing is coming up. So that is another problem with dot notation. And one has to be extra careful with the naming convention. If you are using dot notation, then you must be careful with the naming convention of index labels, which means that they should be continuous. For example, in this particular example, where we have label space 4, it is not continuous and it throws an error called invalid syntax. So that is why I had mentioned here, never use it. Since this particular method works in series, that's why I'm telling you, but in real world, never use it. Now we are going to discuss about the Boolean masking. Boolean masking is also referred as Boolean indexing or the Boolean selection process. It is a process of selecting subset of rows from a series based on actual values and not by labels or integer location. The methods which we have discussed till now, whether it is square bracket notation or dot notation, or the method which we are going to discuss later, that is get method and the lock and ILOC method, all of these method subset selections were done using either labels or integer location. Those selections had nothing to do with the actual values. Now there are few things which we have to make sure when we are using Boolean masking. That is, each of the queries have a strict logical condition that must be checked one row at a time, And the second one is it needs to be of same length of a series. The third thing is it does not work on its own. It works with either with the square bracket notation or with the get method or using lock and ILOC method. So let's do some example and try to understand that how does it work. As I had mentioned, to make Boolean masking work, we need to have a strict logical condition that must be checked one row at a time. So we are going to build up that particular condition now. For example, we want to filter out all those rows that are greater than 2000. What we are going to do here, we are going to create a variable greater than 2000. And we are saying df greater than 2000. Now, what we will do, we will be using this greater than 2000. First, let's see how does this greater than 2000 looks like. So you can see here, it's a Boolean series which has value of false and true. Let me remove head. So you can see here there are some true values and there are some false values. Now what we are going to do is we are going to pass this particular series in the df series using the square bracket notation. And you can see the output. It starts with index position 201 and the value is 2005. And you can see here it has filtered out all the values that are 2000 or below 2000. So this is how you can do Boolean indexing. This is a very important topic and we are going to discuss in more detail when we will be working on the actual dataset. In Pandas, series has a get method that is used to get items from object for a given key. They could be used to access elements for multiple rows in a series. The major advantage of get method is it can be used with both labeled as well as with position based extraction method. Moreover, it returns default value if not found, but it has some serious disadvantages also. Let's do some examples and try to understand that what are the advantages and what are the disadvantages of using get method. So let's say if we want to extract index number 201 using get method, what we can do here. df, the method name is get, and we are going to pass here the index position 201, and you can see here we got the value of 2005, which you can verify from here. Now similarly, as I said, you can use both index position as well as label based. So we have another series called df underscore labels, which has custom labels. Now let's say if we want to extract label 201, what we are going to do here, we can use get method and pass the index position 201 and it gives us the result 2005. Similarly, we can also pass here label underscore 201, and it gives us the value of 2005. So you can see here, even though df underscore labels has custom labels, we can use both index as well as label based methods and extract the value from it. Now let's say if we want to extract multiple values from a series, what we can do here, we can pass a list. Either you can say index based position 10, 15, let's say 30, and you get the values from here. And we can also pass a list of labels, label underscore 10, label underscore 15, and label underscore 30, and you get the same output. So here you can see we can use both index as well as label based methods to extract a subset of the series. But there is one major disadvantage. One of the major disadvantage of using get method is that we cannot pass a range. For example, let's say we want to pass a range of index position from, let's say, 0 to 10 to see the top 10 records in a series. We cannot do that. For example, let's say we want to see the top 10 records. You can see here it's an invalid syntax. If we have done the same thing with the square bracket notation, you see we have got the top 10 records. So this is one of the major issues that why most of the data analysts and data scientists do not use the get method. Another advantage of using get method is we can pass the Boolean masking. For example, greater than 2000 is a Boolean series and it has true and false value. What we can do here, we can pass this Boolean series using get method, and you can see here you get the same result what we were getting here using the square bracket notation. Now there is one problem. You might be thinking, can we pass the same value, because df underscore label has been created from df, but the labels are just different. They are the custom labels, whereas in case of df we have the default label created by the range index method. So you might be thinking, can we pass this Boolean masking using get method in df underscore labels also? Let's do that. It will not work, and I'll tell you the reason why. And it does not work because of the indexing error. See, here we have the custom label, and the greater than 2000 has a label of 0, 1, 2, 3, 4. But if we have passed this thing as a list, this would have worked. So if we have passed this thing as a list, what does that mean is greater than 2000 I'm converting that series as a list, and you can see here this is a list with values of false and trues. Okay, I'm going to pass the same thing in df underscore label. Now it is not related to any series which has a different index. And you can see we have got the same output what we were getting here. But the thing is, here we are passing it into a df series, whereas we are passing list of true and false in df underscore labels. Since it is a list and it is not associated with any index, and that's why it is working here. So those are the few things which you need to take care of before you start using the get method. All these methods which we have discussed till now to extract an element or to subset a series have certain issues, and that's why they are not the preferred method. The preferred method in Pandas to extract an element or to subset a series is by using the lock and ILOC method. One of the major advantage of using lock and ILOC method is that lock method means to extract an element or a subset of a series using label based indexing. And for ILOC method, it means index integer based indexing. Let's do an example and see what does that mean. There is one subtle difference between lock and ILOC method is, and we will discuss about that difference when we will be doing an example. Let us see once again DF series using head method. So you can see here it's a default indexing which we are using here. Let's say we want to get the value of index position 2. What we can do here, we can use the lock method. So that is how we call the lock method, and then we use a square bracket notation. And here we are going to pass 2. And we got the value of 1010. Let's say if we want to get the last value, it is giving us an error because -1 is not a label there, and that's why we are getting an error. Let's say if we pass last value of a series 19799, that is the last value of DF series, and we are able to get the value 4 times 9 and 5. Let's say we want to extract the top 5 records from DF dataset, and we can pass here and 0, 1, 2, 3, 4, which are the top 5 records of this particular dataset. Now here you might have noticed one thing. Number 4 is not exclusive. It is inclusive using the lock method. Since lock method is a label based indexing, last number is also inclusive, and that is why we have got this result. Let's do an example of Boolean masking. So we are using df underscore labels dataset, and we are passing greater than 2000 series. Let's pass the head method. This is not going to give us an output. It is going to throw us an error, and you know the reason why, because of indexing error. If we have passed greater than 2000 as a list, this will work, and I have already explained you why it will work when we are discussing about the get method, and you can see the result. We are getting those results. Now let's try to understand the ILOC method, and as I had mentioned, ILOC method is used for integer based indexing. It's very simple. We call the method df.iloc, and then we have a square bracket notation. Let's say we want to get the value of index 4, and index 4 is 1020. Let's say if we want to see the top 5 records. Now remember one thing, since it is index based integer based indexing, it is the number 5 is not inclusive. Now let's do an example where we are going to pass a Boolean masking list in ILOC method. What we are going to do, we are going to use a DF series, and we are going to call the ILOC method, and we are going to pass greater than 2000 series as a list, and see the outcome. So you can see by using lock and ILOC method, you have got a clarity that where the label based method is going to work and where the index based method is going to work. And that is why most of the data analysts and data scientists prefer to use lock and ILOC method. But remember, there is one major difference, that the last element is not included in ILOC, whereas in lock method it is included. So we are going to end our session here today. In the next few sessions, we are going to import external dataset using Pandas and converting them into data frames. Thank you so much. Have a great day.